Hi, Math 30-2s. Continuing on today with permutations, but today we're going to take a look at permutations with repetitions. So you'll see elements or things repeated in the question, so things that look identical within the question. And when we see that or come across that, the calculation and the way we go about solving for the total number of permutations is a little bit different. Okay, so just jumping into some questions, I will refer to these repetitions and you'll see them as we read through the examples, and I will show you how to deal with those calculations. So part 1 says, a bookstore is advertising signed copies of books about 3 famous Canadian hockey players in the Hockey Hall of Fame: Wayne Gretzky, Patrick Waugh, and Steve Yzerman. The books are arranged on a vertical display stand. One possible arrangement is shown. Sketch all possible arrangements of the 3 books. How many different arrangements are there? Okay, so what I'll do is, instead of obviously drawing out the books with their nice covers like they've done for us, I will just label the Gretzky book as G, the Patrick Waugh book as R, okay, and the Steve Yzerman book as Y. Okay, so I have the Gretzky, the Waugh, and then the Yzerman book. So then I could have the Gretzky book, the Yzerman book, and the Waugh book. Okay, so I started with the G and then switched the R and the Y. So now I start with a different book. So let's say I start with the Patrick Waugh book. Then I could go Waugh, Gretzky, Yzerman, and then I could also have Waugh, Yzerman, and Gretzky. So I've started each row, or the top of each row, with Gretzky and Waugh, so now I'm going to start with Yzerman. So it'll be Yzerman, Gretzky, Waugh, and then Yzerman, Waugh, and Gretzky. Okay, so in total there, you can see there are 1, 2, 3, 4, 5, there are 6 different arrangements. Now again, we should have known that from when we talked about permutations at the beginning. If I have 3 different things, how many ways can I arrange 3 different things? Well, 3 factorial, okay, which is 3 times 2 times 1, which is a total of 6 ways, and that's what we see there. Now, part B says this: the bookstore sells out of the autographed Wayne Gretzky book, including the display copy. The sales clerk now replaces the Wayne Gretzky book with a second copy of the Patrick Waugh book. So you have 2 Patrick Waugh books. One possible arrangement is shown. Sketch all possible arrangements of the 3 books. How many different arrangements are there now? So again, now you can see I have the Patrick Waugh book, another Patrick Waugh book, and then the Yzerman book. So another arrangement could be the Patrick Waugh book, an Yzerman book, and then a Patrick Waugh book. Or I could have an Yzerman book and then 2 Patrick Waugh books. Now that's it. That's all that I can do. And the reason being is because now I have 2 Patrick Waugh books. Okay, and I'm circling them all here in each combination. And the difference is that, for example, in the third one, if I take these 2 and switch them, you would not be able to tell me the difference between those arrangements. I would still have a Patrick Waugh book in position 2 and 3, with the Yzerman book being in position 1. So in this case, there are only 3 different arrangements. So at the bottom it says, complete the following statement. The number of arrangements in B was equal to the number of arrangements in A divided by 2, right? Because there were 6 ways in part A, and I'm going to divide by the 3 ways that were in part B. Okay, so that answer is 2. Okay, and that's how I get this value right there. Okay, so you can see with repetitions there are less permutations. Now it says in lesson 2, we investigated a number of arrangements of all the letters in a particular word. In every case, the letters were different. So you didn't notice that at the time, but now if you look back, you'll see that every word where we were arranging the letters, there were no repeated letters. In this part, we're going to investigate what happens when there are letters which repeat within the word. So to examine this scenario, we start with the word rose. Okay, so in this word rose, just like in the previous examples and previous lessons, all 4 letters are different. So again, it would just be like me saying to you, how many different ways can you arrange 4 items or 4 elements? Well, it would be 4 factorial, okay, or 4p4 as they basically have here. Okay, so 4 items, I'm arranging all 4 where the order matters. That's 4p4, or like I said, 4 factorial. Now, if we change, this is moving on to part A now. If we change the E, okay, in rows, so I get rid of this E, but I replace it with an S, I now have this word Ross. Okay, so you can see in that word Ross, I now have 2 S's. Just like the 2 Patrick Waugh books in the example on the first page, I can't tell those 2 S's apart if I switch them. If I switch those S's, I still have ROSS. I can't distinguish between the 2 of them. So all that happens here is the following, okay? It says complete the last column. So what you would have in the last column here is you would have an S, an O, an R, and an S. Then you would have an S, O, S, R. Okay, and again, these don't have to be in the exact order. S, S, R, O. And then finally S, S, O, R. Okay, so there you go. Now, when you take a look at that, okay, it says complete the last column, which I've done. It says there are no longer 24 different arrangements. Arrangement like ROSE and ROES from the first list become ROSS, don't they? Because this E that I'm circling, okay, has been replaced with an S. So both of those become ROS, and you can't tell the difference between them. So the number of different arrangements of ROS, ROSS, is simply going to be 12. Okay, so there are only going to be 12 arrangements now, okay, that are different from each other. Notice that there are half as many, or 1 over 2 factorial, as many as permutations as there are of rows. So here's what happens is that when I'm dividing by 2 factorial, the reason I'm dividing by 2 factorial is because there are 2 things that are repeated there, 2 S's. So the total calculation looks like this. 4 factorial, that refers to the 4 letters, ROSS. So how can you arrange 4 elements or 4 letters? 4 factorial ways. But now when things are repeated, I have to divide by what's being repeated, and that's the 2 S's. So 2 factorial, and that gives me 12 as a final answer. Okay, so when I move on to B now, you're going to see a very similar thing. In B now, we're changing the O and the E to S's. So now what we have is we have this, RSSS. So what would happen with RSSS? Okay, so if I'm going to fill those in, I'm going to have SSRS now, okay, as the first one in the last column, then S, 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 and then R. Finally, SSRS, and 3 S's and an R. So again, it says arrangements like rows, ROES and RSOE, RSEO and REOS and RESO from the first list now all become RSSS. So the 24 original arrangements is now reduced down to 4 arrangements in total. There's only 4 different arrangements there. So again, it says there are 1 over 3 factorial as many permutations, but that 3 factorial that you see there and there, okay, comes from the following. Again, 4 factorial, there are 4 letters that I am arranging, but 3 of them are repeated. There are 3 S's that are repeating, so 4 factorial divided by 3 factorial is just a total number of 4 different arrangements, okay? So on the next page, it does say there's a pattern in the list on the previous page. It appears twice in a word, we divide by 2 factorial. If a letter appears 3 times, we divide by 3 factorial, okay? And that basically takes us to this right here, okay? The n factorial is the total number of things we're arranging, but the a factorial, b factorial, and c factorial refer to the number of repeated elements, letters, objects, whatever you're dealing with in the question, okay? The number of times those specific things repeat. So what happens is if I go across, or down, I should say, to class example 1 here, it says find the number of permutations of the letter word Vancouver. So the first thing I do is determine how many letters I want to arrange. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I asked you how many ways can you arrange 9 letters, you would just say 9 factorial. But I notice when I look at this question that the V, letter V, is the only letter that's repeated, okay, and it's repeated twice. So I take my 9 factorial and I divide by the 2 V's that are being repeated. So I divide by 2 factorial. So we can use our calculator at this point. So 9 factorial divided by 2 factorial gives me a total of 181,440. Okay. Same kind of idea in mathematical. Start with how many letters in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 elements or letters, things that need to be repeated or ordered. Then I divide by what's being repeated. So what's repeated in this question? Well, I have how many M's? 1 M, 2 M's. So I'm going to divide by the 2 factorial. That represents the 2 M's. Hey, how many A's? I have 1 A, 2 A's, and 3 A's. So I also divide by 3 factorial. And then I also have T's, okay? So you can see I have how many T's here? 1 T, 2t, so I also divide by 2 factorial. Now, there's the calculation. When I use my calculator, however, I must be very careful that I divide by that whole calculation in the denominator. That's why I put brackets around it. So on your calculators, then 12 factorial divided by, and then make sure in brackets, 2 factorial, 3 factorial, 2 factorial, and that gives you a total of 19,958,400. Okay, so again, the number in the numerator factorial is the total number of objects, elements that you are attempting to order, and then you divide by the repeated elements in the bottom. So let's try a question here, okay? It says Brett bought a carton containing 10 mini boxes of cereal. There are 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Pops, 1 box of Shreddies, and the remainder are Raisin Bran. Over a 10-day period, Brett plans to eat the contents of 1 box each morning. How many different orders are possible if on the first morning he has Raisin Bran? So they even throw in a restriction here, which is on the first morning he's going to have Raisin Bran. So what I really want to do on the first is figure out how many of each type of cereal box I have, and they've already told me that the total has to be 10, okay? So I have 3, okay, which are cornflakes, okay? They tell me that right away. 3 are cornflakes. 2 boxes are going to be the Rice Krispies, okay? 1 box of Cocoa Pops, so I write that down on the side here. I have 1 box that is of Shreddies, like so. And the remainder are Raisin Bran. So right now I have 3, 4, 5, 6, 7 that they've told me. So the remaining are Raisin Bran. So that means there are 3 that are Raisin Bran. All right. So that gives me a total of 10. Okay. So this is 10. That's how I know that this number here is 3. Okay. Because the ones before that added up to 7. So 10 boxes of cereal. Now I'm going to deal with, as we always do, the restrictions first. And the first restriction here, or the only restriction, is that on the first morning he has Raisin Bran. So again, just like the questions we've dealt with, I make that happen, okay? It is going to happen no matter what. He's having Raisin Bran that first morning. So what that really does is it takes my total boxes of Raisin Bran from 3 down to 2, and it also cuts the total number of boxes from 10 down to 9, doesn't it? I basically take that box of Raisin Bran out. It does not affect the calculation because it's going to happen. I'm really only concerned now with the 9 remaining mornings and the 9 remaining boxes of cereal because I know he's having Raisin Bran in the morning. So the boxes of cereal here are just like letters in any of the questions that we've dealt with so far today. How many boxes of cereal are there? Well, there are 9. So the way that I can order 9 boxes of cereal is 9 factorial. But of those 9 boxes of cereal, there are cereal boxes or types of cereal that are repeated. There are 3 boxes of cornflakes. Just like 3 letters that are repeated, I divide by 3 factorial. There are 2 boxes of Rice Krispies, and now there are 2 boxes of Raisin Bran. So there's the calculation. 9 boxes of cereal, 3 repeated cornflakes, 2 repeated Rice Krispies, and 2 repeated Raisin Bran. So again, in our calculation, okay, we do that. 9 factorial divided by, and again, brackets around our denominator calculation, and that is 15,120. And there you go. Okay, so again, drawing parallels between questions we've done and new ones you see are really important, okay? Whether it's boxes of cereal, like I said, letters in a word, okay, whatever it may be. If they are repeated and you cannot distinguish one from the other, we must divide by the number of times it occurs in the question. Okay, next. Exploring roots using permutations and patterns. So sometimes these are referred to what we call pathway questions. It says Paul and Catherine are considering, the following problem. Find the number of roots from A to B, and here is the kind of the restriction, but roots must always move closer to B. So what that means is if I start here at A, I can go like this towards B, I can like that towards B because both of those movements were towards B, but I cannot go back this way because that movement would be away from B. The reason they throw that in there is because I could continue to just go around in a square forever, okay, and never get any closer to the end. So they have to say that I always kind of have to make a move closer to B. And you'll see that in every question, okay? That is always a restriction in every question. Now, what they're going to have us do here is draw out every single root. And we can do this in this question because the pathway that we're going to take from A to B is relatively small. But if you get like a 10 by 10 square, you're going to be there for an hour, okay, or hours trying to figure out all the different pathways. So we will have a way of doing this mathematically using numbers and calculations as opposed to drawing out the roots. But we'll follow what they want us to do here. Let's draw out all the roots, okay? So they've done 1 for me in the first one, okay? And again, this one I can go 2 to the right, 1 down, 1 across, and down, okay? The next one I could go all the way across, and then all the way down, and down, all the way across, back down. Then I could go here, 2 across, down, and across. Here, 1 unit across, all the way down, all the way across. This one I kind of zigzag my way down. Then I'll go 2 across, 2 down, over. Here I'll go 1 down, 1 across. Okay, and then the last one will obviously be straight down and straight across. Now, obviously you don't have to do them in that order, or if you wanted to do them on your own, you won't have them in the same order. It doesn't matter. All that matters is that all of those pathways are different. So it says Catherine developed a quicker method. She realized that to travel from A to B always involves moving 3 units east and 2 units south, and that the answer is the number of ways it can be E-E-E-S-S. Obviously, E standing for east or to the right, and S being south or going down. Note that Paul's first grid shows east, south, east, east, south. Okay, so what they're referring to is this one. He went east, then he went south, then he went east, east, and south. Okay, so that's what they're referring to there. Solve the problem using Catherine's permutations with repetitions. So what happens is this. I'm going to show you at the top diagram here, and then I'll come back to the calculation. What I always teach is this. To go from A to B, I just go on the outside of the grid. So I go 1, 2, 3, 4, 5. So there are a total of 5 movements, okay? It's like arranging 5 things, so 5 factorial. That's the total number of movements to get from A to B. Of those 5 movements, there are going to be 1, 2, 3 repeated movements to the right, and 1, 2 repeated movements down. So there is the calculation that we can use to determine the total number of pathways. So again, it does not matter which route you pick, there will always be 5 total movements, and in any of those 5 total movements to get from A to B, there will be 3 repeated movements to the right and 2 repeated movements downward. So my calculation, just as I did up above, would be 5 factorial divided by 3 factorial, 2 factorial, okay? And you will see that that equals 10, which is the number of diagrams we have up above. Now in C, it says an alternative approach is started below. The diagram has been rotated. There is one route from A to C. So to go from A to C, there's only one way to get there. From A to D, there's also only one way to get here. So that's why they have a 1 here and a 1 here. Those numbers are now representing the C and the D on the diagram to the left. There are 2 routes to get from A to F. So from A to F, there would be 2 routes, so they put a 2 here, okay? And then there are 3 routes from A to H. So A to H, there are 3 routes. All of these numbers have been placed on the second diagram, representing basically the letters on the first one. So it says, how do basically the following answers relate? So the first thing they're asking is, how does F compare to C and D? Well, F is going to be C plus D, okay? So F will be equal to C plus D, okay? Then they ask me, or ask you, how does H compare to E and F? Well, H will be E plus F. And then finally, what they will ask me, it'll be a very similar calculation, is how does I compare to F and G? Well, you'll add them together, okay? So I will be equal to F plus G. So what you'll see is that on these diagrams, okay, whether you rotate them, turn them on their side, whatever it is, on the outside of the diagrams, we're going to have lots of number 1s, okay? So 1, 1, 1, all on the outside. You can see I have a 1 here, a 1 here. There are 1s on the outside of the diagram. There's only one way to get to each of those spots. Then to get to this number 2, Okay, I add these two together. To get to 3, I add these two together. So down here, I would have a 3 as well because I add these two together. Here I would have 6 because I add those two together. Here I will have 4 because I add those two together. And then finally add those two together and you get 10, which was the total number of pathways that I got up above using the total number of movements factorial divided by the repeated movements. So sometimes we're going to use the factorial calculation like we have. Oops, I apologize. I should not have done that. Okay, so sometimes we'll use the factorial calculation that I have here, and sometimes we will use this here, okay, the numbers on the outside of the pathway, which is related to something called Pascal's triangle that we discussed in Math 30-1. But for what you guys need to know now, okay, I will show you exactly what you need, what you do not need as we move through the examples on the next page, okay? And actually, I just missed at the bottom of here. It says, use the relationship to complete the second diagram and compare your answers. Well, that's what I did right here, getting 10 and comparing it to the calculation above, which was exactly the same. So in class example 3, it reads like this. A supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall. And they label it for you. No different than the previous question saying you have to go from point A to point B. It says determine the number of routes possible if the bus, and again, here it is, must always move closer, right? There's that thing, must always move closer to the concert hall. So again, you can't make any movements that move back and away from where you are intending on ending up. So they are going to have me do the calculation 2 different ways, using patterns and then using permutations with repetitions. So what they mean by patterns is what I just did in the last question, which was put the numbers on the diagram. So here we go. So what did I say? I said I start here, and on the outside, I always have the numbers 1. So on the outside, I start by putting 1s there, all the way across and all the way down. If you have to, you kind of turn the diagram sideways so you do what we did up above. So first off, what I'm going to do is this. I'm going to go this 1 and this 1, okay, there, will take me to 2 right there. Okay, and then I add this 2 plus this 1 will give me 3. Then 3 plus 1 takes me to 4 right there. And then I follow the same pattern. 1 here and the 2 will now take me to 3. 3 and the 3 there will be 6. Okay, 6 and this 4 will be 10. Okay, and then I continue that pattern. So this would be 4, this will be 10, this will be 20, this will be 5, this will be 15, and this will be 35. Now, at this point, because we're kind of at the end of one grid and starting another, I treat it like the beginning of the first grid. So at the beginning of the first grid, I put 1s across and 1s down. So here I'm going to continue with that 35, but I put 35s across and 35s down. I just continue with that number. It's like I'm starting a new grid. And now I continue my pattern of adding across to get the diagonal value. So 35 and 35 is 70. 70 and 35 is 105. This will also be 105, and that takes me to a total of, at the concert hall, of 210. Okay, that is your final answer. Now, using permutations with repetitions. So when I use permutations with repetitions, okay, and I just have to get rid of this for now so that I can show you, I kind of have two separate, what do I want to call them here? Voyages to get to the concert hall, okay? I have the bus station to here, to the red dot, and then the red dot to the concert hall. I kind of have two separate grids that meet at that corner. So what I'm going to do is I'm going to do the bus station grid here in red, in a red calculation, and then I will do the concert hall in blue, okay? And I'll tell you what we do with those two calculations. So let's just deal with the red rectangle first. So to get from the bus station to the red dot, there would be 1, 2, 3, 4, 5, 6, 7 total movements, okay? And of those 7 total movements, there will be 1, 2, 3 repeated movements to the right, and 1, 2, 3, 4 repeated movements down. Okay, so there's the calculation for the bus station grid. Now, if you were explaining this to somebody, you would say, okay, I've made that part of the voyage, and then you would not say, or I move on to the blue square. You'd say, and now I move on to the blue square. So remember, with and, we multiply. So now I'm going to multiply by the calculation in the blue square. So the blue square, or rectangle, will be 1, 2, 3, 4 total movements. And of those 4 total movements, there are 2 repeated movements to the right and 2 repeated movements down. So there is the calculation, okay? So you just basically figure out those 2 calculations individually, and then you multiply them together, okay, to see what the total answer is. And it should be exactly what we did when we used the numbers on the grid, adding diagonally to get the number below, okay? And it also gives me 210, okay? So both of those methods give me the same answer, okay? They give me the same answer. It doesn't matter which way I do it. Now, here is the exception to that. So a lot of times you'll be able to use both methods or either method. In an example like this, we cannot. And the reason is that up above what you saw was something like this, okay? 2 perfectly joined grids, okay, at the corner with no overlap. In this example, can you see how it's kind of like 2 grids that are overlapped? Or you can think of it as 1 grid that is missing some sections, okay? If that is the case, as it is in this class example 4, okay, I cannot use the calculation where I'm using factorials with repeated movements, because there are some movements or pathways that you are including in that calculation that don't exist. So in a situation like this where we have grids that overlap, or it looks like a big grid where there's 6 sections missing, we must use the numbers that we write on the grid itself. So here's what happens. It says a taxi company is trying to find the quickest route during rush hour from the train station to the football stadium. Okay, so starting here, ending here. Use patterns to determine the number of routes that must be considered. At each intersection, the taxi must always move, and there again, closer to the football stadium. So again, we start by putting 1s on the outside of the grid and down the grid. Okay, and then we continue our pattern of adding. So 1 and 1 is 2, 2 and 1 is 3, 3 and 1 is 4. Now this is where it gets tricky. The number 4 goes here. Okay, why? Well, because it's like there's a 0 here, isn't there? Even though there's nothing there. Okay, I just extend that 4 to the next intersection because there's nothing up above and diagonally to add it to. And then I carry on with my process. 2 and 1 is 3, 3 and 3 is 6, 6 and 4 is 10, 10 and 4 is 14, 3 and 1 is 4, 4 and 6 is 10, 10 and 10 is 20, 20 and 14 is 34, 1 and 4 is 5, 5 and 10 is 15, 15 and 20 is 35, 35 and 34 is 69. Down here, I extend that 15. Again, it's like there's a 0 here to add it to. And then I continue. 15 and 35 is 50, and 50 and 69 is 119. So there's your total number of pathways, okay, to get from the train station to the football stadium. In B, it says explain why with repetitions 9 factorial over 4 factorial, 5 factorial can't be used. Okay, so the reason is that since there are gaps in the rectangle, so here there's a gap, okay, and here there's a gap. So since there are gaps in the rectangle, not every single arrangement or pathway will be 4 east and 5 south, or 4 to the right and 5 down. Okay, because of those circles that I've created there, not every calculation is going to be possible. So you can't use that calculation, okay? There are pathways in 9 factorial, 4 factorial, 5 factorial you're including in that calculation that don't exist because of the gaps in the diagram, okay? And that's it. So that's the end of that lesson. Try that. So again, that's permutations with repetitions. As always, any questions, concerns, email me, and I'll get back to you as soon as I can.